Okay, great. So what can I help you with?
I will work like on the row reduction first, and after that, like we can work on the question 3 point, mm, on the question.
Okay, so shall I open up my math lab?
Okay, yeah,
All right. I'm gonna open up my math lab. Which one are you working on?
4.3. So
4.3? Okay.
yeah, so I'm on number 4.
Number four,
Yeah,
question four. All right, so it, I'm gonna share my screen with you.
okay.
So does yours look like this? Does it have these numbers or does it have different numbers?
Sigma.
Can you see it?
Yeah, it's 1 0 -5 for me. So
So maybe the numbers are a little bit different, but we can
yeah,
still work.
yeah,
So we need to find a basis for the null space.
yeah. Okay.
Okay. So I'm going to stop sharing. If you want to tell me what your, so this is my math lab number 4.3, number four. So can you tell me what your matrix looks like?
So it's like
Are you going to read the columns to me? Why don't you
okay.
read the first column?
It's 1 0 -5 2
Negative five. Okay.
2.
Oh, you mean it's a, what size is your matrix?
So it's 4 by 3, I think.
Oh, yours is a 4 by 3? Okay. So
No,
one,
it's like
zero,
4 by 3 or 3 by 4.
I don't
And
know. How
then
many rows do you have?
I have 3 rows.
It's 3 by 4.
Yeah.
Okay. So 1, 0, -5. Are you reading the row or the column to me?
I was reading the column. Was let me read the row to me.
You're reading the row. Okay, that's fine. We can do it that way. So the first row is 1, 0, -5, 2.
Yeah.
All right, what's the second row?
0 1 -2 4.
4. Okay.
And then the last one is 5 -13 1 -42.
Okay. So we want to find a basis for the null space.
Yeah.
So let's just review what we need to do to find a basis for the null space. If this is A, right,
Yeah.
what we want to do is solve AX equals 0. Okay, and then write the solution in parametric vector form. And that way we can see the vectors that form the basis for the null space. Okay.
Okay.
So did you start solving AX equals 0 with your calculator?
No.
All right, so let's grab a calculator and let's solve this.
Okay. Get my
I've got mine too. Zero, -5, 2, 0, 1, -2, 4, 5, -13, 1, -42. So I'm going to check it and just make sure that it's actually, okay, so second quick, clear. Second matrix. All right. 1, 0, -5, 2, 0, 1, -2, 4, 5, -13, 1, 42. Are you there?
yeah.
I always check my matrix to make sure I didn't make a mistake, you know?
Mhm.
So we're going to row reduce it, right? So second matrix, math. We're going to do RREF for row reduced form. And then we'll put in second matrix, put in that matrix A, and then hit enter again. So this is the row reduced form. Okay, so A turns out to be row equivalent to 1, 0, -5, 2. That's interesting. 0, 1, -2, 4, and 0, 0, 0, 0. You with me? All right, so let's just make sure we understand. This is the X1 column, this is the X2 column, this is the X3 column, and this is the X4 column, right? Because when we
Yeah.
multiply A times X, since A is 3 by 4, we're going to be multiplying it by a 4 by 1, right? That looks like X1, X2, X3, X4, okay? Because A is 3 by 4, since it has 4 columns, we need 4 coordinates, 1 coordinate to weight each column. Got it?
Yeah.
All right, so let's reconstitute this. Let's read off what this actually says, okay?
Okay.
What does the first row say?
So we have to write like,
I mean, we've got zeros here, right? Because it's equal to 0. Okay, so these are all zeros. I didn't put them in the calculator, but they're there. It's always, the zeros never change. Do you understand what I'm saying?
mhm.
All right, so what does this first row say?
So we should like write at the 1x1 or
Yeah, 1x1 or
mm,
just x1.
and we don't have x2, so 0 and -5 x3
Good. Keep going.
and then 2x4
Plus
plus
2x4. Yep.
yeah.
Equals 0. Okay, that's the first equation. What does the
Mm-hmm.
second row say?
So we don't have the first one. So x2 minus -2 x3
Good. We're
and
just minus x3, 2x3. Uh-huh.
plus 4x4
Good.
equal to 0.
Equals 0. All right. Now, let's look at where the pivots are. The pivots are here and here. So x3 is free because it doesn't have a pivot, and x4 is a free variable because it doesn't have a pivot, right?
Mm-hmm.
So our solution x, which is equal to x1, x2, x3, x4, is equal to, okay, so now we solve for x1, right? Bring
Yeah,
these over to the other side. So x1 equals what?
which one we suppose.
You see, x1 minus 5x3 plus 2x4 equals 0. So we need to
Mm.
solve for x1.
So
Take
negative
this
5.
over to the other side as a plus,
Oh, okay.
right? So this will be,
Yeah,
so
5x.
x1 equals 5x3,
So yeah, and
and then
plus
take this over as a minus.
oh -2
Does that make sense?
mm-hmm.
Good. What about x2? What is it equal to?
So plus 2 x3
Good.
and minus 4x4.
Excellent. And x3 is just x3 because it's free. It can
Yeah.
be anything. And x4 is just x4.
Mm-hmm.
So, so now what we want to do is tease out the two I'll do it in two steps. The two vectors. See, I'll just do the x3s. This is 5x3, 2x3, 1x3, and 0x3s plus negative 2x4. I'm just see how I'm grouping together the x4s now.
Yeah.
Negative 4x4. What goes here? Are there
Extra.
are there any x4s? We're just doing the x4s, you see.
No.
So there's 0x4s and then one x4 here. So when we actually, now we factor out the parametric variable, which is the x3 and the x4. The parametric variables are the free variables. So what's left when we pull the x3 out of this vector?
So 5,
Good.
2,
Yep.
and 0. No, 1
Uh-huh.
and 0.
Perfect. You're fine. And then
Okay,
we'll do the same thing and factor out the x4 here so that we can see the actual vector that's getting scaled. See, x4 is scaling it. This is a scalar. It's called the parameter. These are the parametric variables. Okay, so what goes here?
So negative 2,
Mm-hmm.
negative 4,
Yep.
0,
Yep.
and 1.
Good. And so the basis for the null space is the set that contains these two vectors that are getting scaled. In other words, it's all linear combinations of those two vectors.
Okay.
5, 2, 1, 0, negative 2, negative 4, 0, 1. And so I think if we look at the way that you put in, so over here, like when you put in your solution, when you click on that, you're going to want to put in a vector, but you tell it it's going to have 4 rows and 1 column because it's going to be a vector that looks like that. See? So there's going to be one of them. And then after you finish that, get out of it and put a comma because we put a comma between our vectors. And then you can
Okay.
put in another vector that's 4 by 1. Right? And then you'll put the correct
Yeah.
numbers to build those two vectors. Does that make sense?
Yeah. That.
The basis for the null space is, oh, I'm sorry. I thought I was sharing that. I thought I was
Mhm.
sharing that. Okay, so let me show. Do you know how to do that? Do you know how to put those in there?
Yeah, I do.
You do. You know how to
Yeah.
put two, and you put a comma between them because the set brackets are already there, right? Like I'll
Okay.
show them to you. We can put spaces in here. You can see that the set brackets, they already gave us the set brackets, right? So our job is just to put in the two vectors with a comma between them. Use a comma to separate the vectors. And so you'll just put your two vectors in there.
Mhm.
So that's the way that we solve for the basis for the null space, because the null space is the space that is the solution set to ax equals 0. And that is, see, this is a linear combination of these two vectors. X3 can be any scalar. X4 can be any scalar. So when we just pull these vectors out, this is the basis because by definition, the basis is the vectors such that the space is all linear combinations of those two vectors.
Okay.
This is called a linear combination of this vector plus this vector. Does that help?
It does.
Good. What's another problem that you want to look at?
Mhm. Let me see.
Sure. Because the other kind of main thing would be to find a basis for the column space of A, right?
Mm-hmm.
Is there one of those?
Can we do number 7? Because
You just tell me when you have a problem number that you want to work on.
No, I said number 7.
Number 7?
Yeah.
Okay. Number 7. Okay. So number 7 says assume A is row equivalent to B, right? Find the basis for the null A, column A, and row A. All right, so let's review the process. You already know how to do null A because we just did that, right?
Yeah.
Like
Yeah.
here's the row, this is B is the row reduced. So it would be
Mm,
really good practice for you to go ahead and tease out the basis for null A, right? Do we want to do that one first?
yeah.
Like you
For
might have different numbers.
yeah. I think it's different.
Okay, so I tell you what, for number 7, what are the numbers that you have in A? And is your A 4 by 5 the way mine is? I bet it is.
Mm,
4
mm,
rows and 5 columns.
yeah.
And your B is 4 rows of course and 5 columns,
Mm, yeah.
right?
The same thing.
Okay, right. All right, so what are the rows in your A? What,
So do you want me to? Okay. I'm gonna
or,
read it like.
or do you want me just to do mine and do an example for you?
You can do yours and I can follow that and do mine.
Okay, so
It's
1,
easier.
3, 5, -4, 6 is my first row. 1, 3, 0, 1, 6 is the second row. 3, 9, -5, 8, 5 is my third row. And 2, 6, 0, 2, 5 is my last row. All right, so when it's row reduced, B looks like 1, 3, 0, 1, 7, 0, 0, 5, -5, 5, and this isn't a 17. These are two different numbers. This is a 1 and a 7. And then third row is 0, 0, 0, 0, -8, 0, 0, 0, 0, -8. And my last row is all zeros. Does yours look kind of similar? It may not be exactly,
Yeah.
but it's similar. All right,
Similar.
so I'm looking
Mm,
at the pivots in B. My
mm,
pivots are, let's see, x1 is a basic variable because it has a pivot. But x2, my x2 is a free variable because there's no pivot in column 2.
mhm,
Column
mm.
3 has a pivot, so x3 is a basic variable, not a free variable. Is your column 3 also a basic variable with a pivot?
Yeah.
Great.
Mm,
X4, mine is free, there's no pivot. And X5, mine has a pivot. Does yours have a pivot?
mhm, yeah.
Okay. So for null A, right, X is going to be X1, X2, X3, X4, oops, X5. Now I know that I'm going to be waiting with X2 because it's free. And then I'm going to be waiting with X4 because it's free. All right, I'm going to do this we'll do this together. So when we're solving for X1, X1 is -3 X2, right?
Mhm,
Because this is X1 plus 3X2 plus X4 plus 7X5, right? So I'll take
yeah.
this over as a -3. So the X2 has a -3 here in the X1 position, right?
Yeah.
And then the X4 is going to be a negative X
I get it.
negative X4. So it's a -1. Okay. All right. So X2 is free. So I'll put a 1 here and a 0 here because right? Because X2 is just X2, right? X4 isn't X2. But down here on X4, there's a 0 at X2, but a 1 at X4 because X4 is equal to 1 times X4. Do you see that?
Yeah.
Great. Oh, you're a quick study. All right, so let's figure out what x3 is. Okay, so this says,
Go
oh wow. So we actually need to go a little further, but this is easy. We can just take this whole row, right, and divide
ahead.
by 5.
Oh, okay.
See what I mean? Like they didn't completely row reduce it. I would take 1/5 row 2 and replace row 2. Do you see that?
Mm,
So this would become a 1, a -1, and a 1, right?
yeah.
So 1x3 would be, well, equal to the negative x4 goes to the other side as a positive x4. Oh, no, 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 I can't do that because then we've got to keep going. No, we can't use this. We can
Mm,
use, to get null A, we have to keep going. Oh gosh, yeah, I just realized that. We have to keep row reducing this because we need a completely reduced form to get the null A. So B is row equivalent to, all right, so let's do the row operations to completely row reduce this, okay?
mm,
So we can take -1, no, +1/5 row 2 replaces row 2, and at the same time we can say -1/8 row 3 replaces row 3. You agree? So that
yeah.
gives us 1 3 0 1 7 0 0 1 -1 1 0 0 0 0 1 because I'm dividing by -8 or multiplying by -1/8. All right, but now we're not quite done because we've got, this is a pivot, this this is a pivot, but this is a pivot, right?
Yeah.
So we got to clear this column, but that's not hard. We'll take row 1 minus 7 row 3 is row 1, and smarter people than me would do this in their heads. And row 2 minus 1 row 3 is row 2. It just disappears those. It doesn't change anything else. Like I'm saying, smarter people than me would just do that in their head. But anyway, I mean it clears the 7 and clears. Now we can see. Now we can see. So let's reconstitute that. So we have to go further for Nole. My bad. It was a little tricky problem. They didn't completely, I didn't realize it. I didn't really look at, I mean, these are the pivots and this is fine for showing us how to find column A. Like this is all we need to find the column A basis. And this is all we need to find the basis for the row A. But to find the basis for null A, we have to completely reduce. All right, so here we've got x1 plus 3x2 plus x4 equals 0, right? And then we've got
Yeah.
what? X3 minus x4 equals 0. And then we actually have that x5 is equal to 0. X2 is free and x4 is free. These are the free variables. All right, so here we go. So x is equal to x1, x2, x3, x4, x5. And x1, now we can solve for it. I can actually see it now. I can do this in one step. It's going to be -3 times x2, right? So the x2 is going to be the free variable that waits, and it's going to be a -3 times x2, right? Plus the x4 will go to the other side as a -1 times x4, so the -1 will be there. So that's x1. It's -3 x2 minus x4. Do you agree?
Yeah.
Now x2 is free, so we put a 1 here, right? Because
Okay.
x2 is 1 x2 plus 0 x4. It's just like here for x4, we put a 0 here and a 1 here.
Okay.
But what's x3 going to equal?
So 1, -1,
Take it the other
1,
side. Take it the other side.
1
1 times what?
times 0.
Oh, no, no. x3 equals, just take the negative x4 to the other side as a positive x4.
So it's
x3
gonna be
equals x4. Here, x1 equals negative 3 x2 minus x4. x3 is actually equal to x4. Do you see it? So x3 is 0 x2 plus 1 x4 because x3 is equal to x4. Does that make sense?
yeah.
But x5 is actually 0, so it's 0 here and 0 there. Because x5 is not free, it's actually equal to 0. That's what it means to have the 1 here. I mean, this means 0x1 plus 0x2 plus 0x3 plus 0x4
0.
plus
Mm-hmm.
1x5 equals 0. That means x5 is actually equal to 0.
Okay.
Does that help?
Yeah.
So the basis for null A is these two vectors that are 5 by 1s. Now, the basis for column A, what we do is we see the pivot columns already. The pivot positions even. The pivot positions are
Mm,
here, here, and here. So these are the three vectors that are the basis vectors for column A. You have to go back into A to find the basis vectors for column A because row operations change the column space. Remember how we talked about that in class, that row operations change the column space? They don't change the row space, but they change the column space. So you take 1, 1, 3, 2 as one of the vectors, 5, 0, -5, 0 as one of the vectors, and 6, 6, 5, 5 would be the third vector for column A. So if we call this vector 1, vector 2, vector 3, vector 4, and vector 5, the basis for column A is vectors v1, v3, and v5. This is from A. You have to go into A to find the column vectors for column A, okay? You, you take the pivot columns.
okay.
And even though that doesn't seem like it's a pivot, it is. The pivot positions are these positions that correspond to the pivot positions in the reduced form. And finally, for the row space, row A, I hate that I made this mistake. I'm gonna get rid of this. It's driving me crazy. There's some whiteout. I'm keeping the whiteout company in business myself. I should just invest in their stock, I swear. Okay, so for row A, the non-zero rows are the basis for row A. And you can take the non-zero rows of B because row operations don't change the row space. Take the non-zero rows of the reduced matrix B, or you can take the corresponding rows from A, or the pivot rows. These are the pivot rows from A. You can do either one. So a basis for row A could be, usually we write them horizontally. 1, 3, 0, 1. 7 is one basis vector. We usually write them, like I said, horizontally, 0, 0, 5, negative 5, 5, or 0 and 0, 0, 0, 0, negative 8. You can take that. You can write them that way. And it'll accept them. You just use parentheses and commas between the coordinates and also commas between the row vectors. So you can, it's just as easy just to take the ones from B as it is to take the pivot rows from A, but either one would be correct.
Okay.
And this is in the notes. We did examples of these in the notes, so you can check the notes too if you want to see some more.
Good.
Other questions? Do you want to look at another one? Do you understand this?
Yeah, I did. Thank you.
You're welcome. You want to look at another problem? Take your time. You're here, right? I was going to
Yeah.
sit here by myself, but you're welcome to. I'll pause the recording, and then